Welcome to my channel. I'm Zhang Xu. Let's look at the problem 26 in chapter 23. Chapter 23 is about electric potentials. So there we can see we have 2 point charges, Q1 and Q2, right? Q1 is positive, Q2 is negative. We write it as there. The distance between them is d, 0.05 meter. And this one is given. And then ask you at which position the electric field density is 0. So we can see the Q1 is positive, so the electric charge will be the radically outward. On the x direction, it will pointing to the left. Agree? It pointing to the left, and there pointing to the left. And the Q2 is a negative charge, so the electric field density will point inward to it, so it will look like this one in these two regions. Now you can see at where it can be 0, so that means these two vector E1, E2 cancelled, so it must be at this region, right? Just at this region, the left side of the Q2. Agree? Yes. And then we consider this number as x, right? Now we can write down the electric field density E1 in this location. So we just use the point charge Q1 is positive divided by 4 pi epsilon naught, and then distance squared. We can see the distance is x plus d, right, squared. And then we look at the E2. For E2, it's the electric field density by the Q2. So we use the point charge Q2 divided by 4 pi epsilon naught x squared, because the distance between this point with the Q2 is x. And then we know Q2 is negative charge, so there we take the absolute value to just get the magnitude for E2. And then we know E1 minus E2, this is the electric magnitude, right, equals to 0. And then input E1, E2 inside, we can see we can get the function for x, look like this one. Input all the given quantities, get answer there. The next one is ask you the potential is 0. So as we know, we can find the point charge potentials as Q divided by 4 pi epsilon 0 and then distance squared. Agree? So that means if we want to make the potential is positive, it may be at there, it may be at there, right? So first one, we look at the position x1. So we find the potential be from the Q1, we write it as V1 as the point charge Q1 divided by 4 pi epsilon naught. Now the distance, this distance is just d minus x1, right? So write it as there. And the V2 from this one is just the Q2 divided by 4 pi epsilon naught x1. And this V1 plus V2 equal to 0. So you input V1, V2 inside, and then get the function for x1, look like this one, then input the known quantity, get answer there. The second possible region is x2. So for x2, we still can read the potential from the Q1 as V1. So it's Q1 4 pi epsilon naught, the distance is d plus x2, right? Because from there to there. So d plus x2. And then from the V2, it's just Q2 divided by 4 pi epsilon naught x2. And then we add these two vectors together. It should equal to 0. So 4 pi epsilon naught, 4 pi epsilon naught equal to 0. So we get the function for x2. Input all the given quantity, we get answer there. Thank you.